But here's kind of a color mapping of some of the grades in the class. And if you look, we have kind of a division. We have two different grade calculation methods. And you really can't see the colors, I'm sorry, but the blue ones are A's, and the red ones are F's, and you know, the pale brown ones are probably D's, maybe C's, and the green ones are B's. So anyways, I calculated grades two ways. One was counting absolutely everything, and one was leaving off the daily, you know, the lectures. So, you know, the online students, if they weren't doing the lectures, then they still had a chance of making a good grade. And for that person, that made a lot of difference. So that means that they're doing the homework and the quizzes, but not the lectures. Okay, as long as you get your programs done, I'm going to be happy. So I was trying to figure out why we either had A's or F's. That's unusual, you know, and one B, good for B. You know, and scroll down and see the rest, but they all follow the same pattern. So I looked, and if I cut off the quizzes, then, you know, that helped one person. So if that person goes in and does the quizzes, great. If we look at the homework, you know, a fair portion of the class is doing their homework and a fair portion of the class is not. And pretty much if you're not doing your homework, then no matter what, your grade calculation is going to be a bomb, right? And then the in-class assignments, the lecture averages, you know, kind of correspond to that. But since I said that grade estimate calculation method 2 doesn't include them. And then the quiz average. And you can see that, you know, a lot of people have done the quizzes, but a lot haven't. So take the quiz again if you didn't make a good grade on it. And for heaven's sake, if you haven't taken the quizzes, get them done. They count for points. They count for points quite a bit. 5 quizzes is equal to 1 exam. Yeah, so they're important business. And you have considerable time to do that. So I've posted a whole bunch in D2L about taking the exam. You can either sign up Proctor U so that you can take it at home if you want somebody to watch you over your webcam, or you can come on campus to do it at the Learning Resource Center, or you can sit in on one of my classes. Just email me so I make sure that you have time. I mean, that there's enough room for you.
So a lot of people actually use Proctor U.
I had much larger advanced Java last semester when it was online only, and yeah, a lot of them took Proctor U. But it's not their favorite way of taking it. But we're supposed to not allow anybody to take an online exam without it being proctored anymore. You know, the old days of letting people take them, you know, at home without a proctoring service is unfortunately gone. So in the news, I provide some links, you know, the pricing of it. The pricing is set up so that the further ahead you schedule it, the better off you are. That doesn't seem to be showing that. Take it now is $8. Take it soon is $5 at premium. So those are additional fees, you know. Otherwise, schedule it like 72 hours before the desired start. So what is that, 3 days? Yeah, so 3 days before start. Otherwise, you pay a little bit of a penalty. Not that huge. I don't remember how much it costs to do it. I guess that's it, right? You'd want to, the exam is set up for 120 hours, so you'd want to choose a 61 to 120 minute. Alrighty. Hope that's enough. Now, we had talked about peeking back in on Chapter 7. I had an unnerving feeling that maybe there was something that we hadn't covered, or since it's been a while, that it was fading in our brain. Go away. Okay, we know how to assign a reference. You create a variable, and then when you do your equals new car, that creates a reference and stores it. And then if you want to, you could store that reference in another variable. And it's the same object that they're both pointing to. So Stacy car is now pointing to the same object that John car is. And so if you change the color of Stacy's car, it also changes the color of John's car because they're the same car. I guess they both own it. My simile is always 2 street signs pointing to the same street. You burn that street down, it's burned down for both, you know. You have 2 signs pointing to a burned down street. So that is important for, among many other reasons. If you have 2 variables, A is equal to, new integer, 3. Not that you ever do this, but you could, And then if you want to see, if A is equal to B, then print the same. Obviously, this is not going to print the same, is it? Yeah, we're good. But then what if you made this a 3 as well? It's not going to print that they're the same. Why? Because all this does is check the addresses. So it would not say these are the same because they're not the same reference. Now let's copy that code. Changing one thing. A is equal to new integer. B is equal to A. Now they are the same. But if you turned around and created a new integer, and tried to compare it, again, it would say that they were false, no matter the value. And this should disturb you right here. The fact that you think that it's checking the values and it's not. Similarly, strings. If you do something like this, X is equal to Joe Bob, and then you do Y is equal to Joe plus, come on, Bob. If you print them out, they're going to look exactly the same. But if you do if X is equal to Y, nope, even though the contents look the same, they are not the same reference. And that's different than it is in Python. It's different than it is in C++. In C++, you can override the behavior of the equal. I think you can do it in C#. Can't do it in Java because in Java it's just comparing the address, the reference. So what you got to do is if x dot equals y. Yay, this does it. Dot equals is a method that checks, not to see if they are the same address, but are the same value. And I bet if we did that up here, that A and B, being of the integer class, could do the same thing. If A dot equals B. Now the wrapper classes are kind of a weird beast, and it may be that you don't exactly have to do it that way, but to be absolutely sure, you want to use dot equals. And that's why we like to add our own dot equals method. So our rules of thumb, guidelines, Thompson's guidelines, methods public, data private, getters and setters, which is necessary if your data is private. Then constructors, if it helps. Create the objects. Why would you do that? So you can do things like, voter is equal to, new voter, Bob the Democrat, right? You wouldn't be able to do that if you did not add if you didn't have a custom constructor. As well as that, if you ever think that they're going to be comparing objects and you want to compare by values rather than equals, you need to provide a dot equals method. And I always say add a toString method, just to make it easy to debug. You can print something out and see all of its data. And 6, add a dot equals method for comparison. If you want to be able to sort these items, there's another method that you're going to want to add. And when I say add, what I really mean is override. That's a term that we're going to get to, hopefully today, when we jump from this chapter to 13. Same for this one. What is overriding? Well, every object has a toString method already built into it. But all it does is print out the hash address. You know, it doesn't give you any useful information. So if you try to print, you know, if you make a dog class and you create a new dog and you try to print it out, it's going to call toString, and all it's going to return is an address that it's going to print out, you know, hexadecimals. It's not going to be any use. So you want to replace their toString method with one of your own, a useful one. And that's called overriding. The reason that every object has a toString method is not because they added it to every method under the sun, including the ones you added. It's because the root class, the superclass, the parent class for all of them has a toString method and a dot equals method. And we get to override them to do the good stuff. And I think we ought to make one more class that has all of this stuff. Just a simple kind, maybe a point XY, you know, kind of class. But we're going to go ahead and do it. I don't want to take more than 10 minutes typing this part of it. Okay. Let's go on and see if that makes sense. So we know how to assign a reference. We just use the equal sign. To test objects for equality, you better not do that. Even though these cars are both red, they're going to return false because they're not pointing to the same address. So instead, you're going to have to write your own dot equals method. We will do that. Passing references as arguments. That's a good thing to talk about. Method call chaining. Honestly, I don't give a hoot about method chaining, but I guess I'll mention it since the book does take all of 3 minutes to mention it. Overloaded methods. We will certainly mention that again. Incredibly important. I think y'all know what an overloaded method is at this point. It's a method that has the same name but different parameter lists. I'm pretty sure y'all know what constructors are. You can overload constructors. You can have different constructors. You can have a default one that doesn't take any data, and you can have another one that takes a double, and you can have another one that takes a string and a double, or whatever. I'm just stepping through this to make sure that I think that we have covered it. If you don't agree, let me know. Okay. Class variables versus static variables. I know I lectured on that last time. We drilled in on the meaning of static. I think we know what scope is. Scope is the visibility of the variable. If it's a local variable, it's only accessible inside that method. But if it's an instance or a class member, it's available throughout that class, given the restrictions on static versus non-static. This is disturbing to me because my next assignment is called Piggy Bank, and I'd forgotten that they gave some code that looks similar to it. Oh well. Alrighty. So, I don't think we're too bad off here. On the quiz questions, Java's garbage collector manages the communications between CPU and main memory. I don't even know what that is. Searches for inaccessible objects and converts their space to free space. That is true. So like up here, if I did this, A is equal to new integer, B is equal to new integer, and then later I did A is equal to B, nothing is pointing towards this one anymore, right? This replaced the contents of that address and stored it in A, so that's now an orphaned object. Nothing points to it. The garbage collector has to come along and release that memory. In some languages, like C++, you don't have the benefit of a garbage collector, and you have to go to a considerable amount of work to make sure that you release memory yourself when the object is done. And if you fail to do that, you get what's known as a memory leak, where your program, the longer it runs, the more memory it eats up. Never releases it. All right, so I'm going to make a new project. And we're going to make a class called voter. Very similar to one of our quiz questions, I think. Probably won't be the exact same thing. Now, I absolutely should put it in its own class, in its own file, And again, as is my want, I'm going to put it in the same file, and this is really stupid. I shouldn't teach you this. So class voter. It's going to have two parts. It's going to have a name and a party affiliation. So string name, comma, party. And let's make a constructor to make it easy to call. And what did we say? We want our data private and our members public. So our data needs to be private, which means we're going to need getters and setters. We could cheat and let NetBeans provide them just with refactor. Refactor, encapsulate fields, and then check the ones that you want. Since we haven't saved this document recently, it seems to not want to do that. Yeah, but I'm going to add them anyways by hand. You may not have NetBeans available to you while you're taking the exam. So these need to be public, getters and setters, because if you couldn't call them from the client, then they're not very useful. So I'm going to need setters for both of them, and I'm going to need getters for both of them. Why don't I provide the getters first? Because they're the easiest. They need to return a string because both of these are strings. So get name, and just return this dot name, semicolon, end curly brace. Same thing for get party. Public string get party, parentheses, end parentheses, return this dot party. Now I need setters. The setters probably ought to be void. Why do I say that? Because we don't care. It's not that we don't care, it's just that we're trusting. Now if your setter actually needs to do some kind of data validation, like you want to make sure they're not entering a bad date or something, then yeah, make it a Boolean or something rather than a void. But we're not going to be validating the name or the party, so we're just going to set them to void. So set name, and it needs to take a string. I like calling the string the same name as the variable that it matches. So this dot name equals name. And I'm going to do the same for party. Public void, set party, and it's going to take a string and set this dot party equal to the argument that's passed in. String party, this dot party equals party. All right, we've made our data public, we've made, private, we've made our members so far public. And we're going to add a constructor. Why are we going to add a constructor? Because if I don't do that, then down here, when I create a voter, it's going to look like this. Voter v1 is equal to new voter, and then I'm going to have to set those things. v1.set name, Bob. v1.set party, Democrat. But I would like to be able to do this. I want to be able to do this. Voter v2 is equal to new voter, and pass in, Sue, and she's a Republican. Like that. And I'm not going to be able to get this to work. It's already highlighted as red saying, hey, you can't do that. So I'm going to make a constructor. A constructor is a method that has the same name. It doesn't have a data type. So public voter, and if it accepts parameters, we need to list them here. So string name, string party. And then in it, we're going to set this dot name equals name, and this dot party equal to party. Now, do I normally put more than one command on the same line? No, but I don't like scrolling up and down when I'm trying to put as much code on the screen for y'all with a big font. And I could even, move that brace up to there if I wanted to. It's a little harder to read in my opinion, but it's a very common style. All right, that looks great. I'm going to save it, and then I'm going to come down here and I'm going to see, oh, that blew that away. All of a sudden, this other syntax, the old syntax, no longer works. And why is that? We have no more default constructor. Once you provide a custom constructor, a parameterized constructor,
Java, for whatever reason, stops giving you a default constructor. I guess that's to force you to use your new constructor. So we're going to add a default constructor, which doesn't take anything. And all it's going to do is set this .name equal, whoops, what am I doing? I don't need to get that miserly with space. This .name is an empty or default or something like that. And this .party is equal to an empty string, or the word default or something like that. And we could fill them in with tildes or whatever, just to let, to indicate that they were done. But I'm just going to do that because that's what it did originally, right? Actually, it didn't even create spaces, default values for them. We could have created default values for them by coming up here and saying equals empty quote, when we did our declaration, but I didn't. Okay, so now all of that should work. ToString method needs to be public, needs to return a string. It needs to have this exact syntax, ToString without any parameters, and it's just going to return a string. I'm going to make this one as easy as possible. Return this .name plus a space plus this .party. Usually I go to a lot more trouble, right? I put parentheses around it, and I use .format and placeholders, but that's enough. Especially enough for our example. Again, I'm going to move my curly braces up to the line before, just to try to get a little bit more on the screen at the same time. We've almost got the whole thing still on the same page. Not quite, but that's too bad. All right. But if we create two voters of the same type, I'm going to create one more voter named Bob the Democrat using our new syntax. So up at the top, I'm going to do voter v3 is equal to new voter, Bob, comma, and he's a Democrat. I didn't put quotes around Democrat. Slow me down if I'm typing too fast. And then I'm going to scroll down a little bit and do a comparison. And it's going to demonstrate that they're not the same voter even though they got the same data. Now there's the concept of a factory method. And a factory method is one that generates an object of a specified type. You say, I want a new voter, and instead of calling its creator, you call, voter.factory or voter.make, and it makes a voter for you. And why would you do that? Because there may be other things that you want your code to do besides just create that object. Maybe you want to give them all consecutive numbers, some kind of voter sequence number, or maybe every time you create a new voter you want to write it out to file or something like that. So at a later point I hope that I talk about factory methods a little bit more. Okay, so I have two of these guys who look like they're the same. Both of them, if we printed them out, system.out.println, voter 1 plus a space plus voter 3, they're going to look alike. They both should say Bob the Democrat. So I just added that line. Kind of confusing because I put these in the opposite order. I just added that line. Now I'm going to check them. If v1 is equal to v3, system.out.println, same. Else, system.out.println, different. That's not good. Not going to work. When I run it, it's going to say that they're different even though they have the same data. There we go. They're different, but they were both Bob the Democrat. So we need to add a dot equals. And we think, well, I learned it with strings, so I'm going to change this line right here. I'm going to space this out so it's not so ugly. Add a return there and a return there. So if v1 dot equals v3, is that going to fix it? No, because all equal equal does is call dot equals anyways. No, that's not true. But dot equals is just comparing references, just like equal equal, until we replace dot equals with our own method. So we run it. It still says they're different because we have not added our own. We have not overridden. We have not added a method called dot equals that checks the name and checks the party affiliation. So we're going to scroll up to our class and do that. So now we're back in the voter class. I'm going to just put end voter class here. We can keep track of where we are. Public. Now it's comparing them. So what does it have to return? It has to return a Boolean. And it just has the names equals. But it has to take in an object because that is how it inherits. That's what it inherits from the root object class, is a method called dot equals. Now we're going to have to turn that in to our own type. And I know that I've shown a fancy way of checking to make sure that we were checking the right type. Last time we broached this, I'm going to shorten that and just expect that we have the right type. So we need to create a new voter from this. So we just need to cast it. Because whatever is being passed in here is what we're trying to compare with our original voter. So voter, I'm going to call it other, is equal to the voter version of the object being passed in. Now that we have that, we can compare them. Let's set up a variable. Nah, let's not set up a variable. Let's just start doing comparisons. If other dot name dot equals this guy's name, this dot name. But if all that is false, we want to return a false. So if that equals is false, you know, we could reword that with not in front of it. I'm going to do that. I'm going to take the equal off, and I'm going to put the exclamation mark there, then return false. And I'm going to do the same thing for the party. If other dot party dot equals, and we're having to use dot equals because I've already told you, shown you that we have to do that with strings. Or if I didn't show you, you just have to trust me on that. Strings are objects. They have to be compared with dot equals. This dot party. So if not other dot party dot equals, this dot party, return false. Otherwise, return a true. And yeah, you could word this a lot of different ways. You know, you could just check this one and check this one, return true, else return false. But I like doing it this way because it makes it really clear. You add more members, you add more comparisons. Guilty until proven innocent. It has to run through all the tests before we return that it's true. And we see that these little things have the little notifications. Add the override notation. Add the, I don't know what that's going to do. Whoa, no way. Alrighty. Add the override notation. That's just for the compiler's sake. And I'll show you why. What if I goofed up and I thought that this was already a voter, that I didn't have to make it an object? Since I have the at override notation, it's saying, oh, that's the wrong definition. The method does not actually exist. And that's because there is no equals with a voter parameter that we inherit from anybody. So we're going to make that back to object. Object is the root class for all types. And every class has an uppercase O. Alrighty. So I hope that demonstrates it. Now when we run it, it's going to say those two voters are different. I'm pretty sure that we did this as a homework assignment. I'm also fairly sure that a fair percentage of the class has not done that homework assignment because a fair percentage of the class is kind of skipping homework, which really worries me. I don't want 50% of the class to fail, and I haven't had this problem to this extent before, which means I'm doing something wrong and I don't know what to do to fix it. Alrighty, so if I run it, it's going to say that they're the same because I added a dot equals method. This is a great time to start talking about inheritance because dot equals is an inherited method, and so is dot toString, wherever that was. And by the way, when is toString invoked? It's invoked automatically when we are given a reference, but it's expected to be a string. Is v1 a string? No, it's a voter. But this will turn it into a string because this has to be a string, so Java goes, okay, I better call your dot toString method. Same for that one. It's a mystery to me how primitive data types get turned into strings in a case like this, right? Because if that was 12, it would print it. And I don't know where the toString method for a primitive type is because in this language, primitive types are not classes. All right, so we're going to, is this okay, guys? Have we got it all? I know that you wait and watch it again. We good? Okay. We're going to go to chapter 13. Now, it looks like a big leap from 10, but if you look, 11 and 12 are kind of peripheral topics. Read the books over them because you want to get the maximum value out of the class. But then we get to inheritance in chapter 13. Why is 8 and 10 also repeated? PowerPoints. I don't mind. Alrighty. Guess I'm skipping 8. Like I said, I'm skipping 10 as well. We're not skipping them. They were in the other chapter. Why is that there? 13. So the difference between composition and aggregation. Now we're getting into some new terms. Prior to the chapter, all of our objects have been relatively simple, right? We have some data, and the data is some primitive variables and some strings. But for an object that's more complex, you might break it up into subcomponents, sub-objects. So you're writing a game that has, Pokemon monster class. And the Pokemon monster class has an attack method, and they have a defense method. Or maybe they have a whole bunch of different attack methods and a whole bunch of defense methods. You could write a class called attack method and another class called defense method, and then put objects of that type inside your monster class. So when the whole class is the exclusive owner of the parts class, that's called composition. It's composed of. So that Pokemon is composed of attacks and defenses. Now they're going to give us a better example here involving cars in a car lot. So the concept of composition is not new. It's how we describe complex objects in the real world. Every living creature and most manufactured products are made out of parts. And I'm made out of fingers and stomachs and brains and stuff. Each subpart is a subsystem that is made of its own parts. My fingers are made out of, metacarpals and blood vessels and stuff. And those things are made out of cells, right? So together the whole system forms a composition hierarchy. Person, finger, metacarpals, cells. They have their own human body composition hierarchy on the next slide. So remember that with a composition relationship, the component is limited to just one owner at a time. The heart can only be in one body at a time. Now we're not talking about types like blood type. This person has blood type A and so does this. The blood cells are only in one person's body until you get a transfusion and it's taken out of that body and put in another one. So here's their example. You've got a human body, and you've got a brain, a heart, a stomach, and he's got bones and muscles. Muscles are made out of cells. Cells have nucleus and mitochondria. Mitochondria are made out of molecules, and molecules are made out of atoms. This is what's known as a hierarchy chart. And in my previous semesters for fundamentals, I've skipped hierarchy charts, but our new textbook shows them. So anyways, what this line means is that we have a brain. It's part of the human body, and it's a filled little diamond, it's a black diamond, which means that it's a composition hierarchy. If it's a hollow diamond, it means something else. And the line goes from the object to the class that owns it. You might think we go reverse, right? A body has bones, and a body has a stomach, and a body has a heart. Yeah, they do it the other way. The bones belong to this body, the stomach belongs to this body, the heart belongs to this body, and that's why they draw the lines going that way. But then there's aggregation. That's if you have something that is owned by more than one class. Students. This class is being attended to by multiple students. So if you had a classroom object that you were putting inside the student object, references to it, you would have multiple references to the same class. That's called aggregation. They say it's a weaker form of composition. With aggregation, one class is a whole, and other classes are part of a whole, just like composition. But there's no constraint that requires the parts to be exclusively owned by the whole. Right? A body, you're pretty much exclusively owned. But what if you have shoes that you're sharing with somebody? The shoes are not necessarily owned by one person. They could be owned by several different people. So that would be an aggregation relationship. You could have many, many, many people sharing the same car, right? Not everybody has, not every car has just one owner. If that was the case, then the relationship would be composition. But since the same car can have multiple owners, or multiple people who use it, that's aggregation. Some examples. Implement a school as an aggregation. You create a whole class for the school, and you create part classes for the different types of people who work and study at the school. However, the people are not exclusively owned by the school, because they may be attending more than one school. A person can attend classes at two different schools and be part of two school aggregations. So the same person might even be part of a third aggregation. Or maybe you have some other kind of relationship, like a household aggregation, something like that. So we have a car dealership concept. Every car dealer has a car, one or more, or zero or more if it's out of business, a manager and a salesperson. And then the car dealership contains the three part classes. So we got, a dealership, and it's got objects in it, right? It might have a car object, but this is kind of dumb because we're probably going to have more than one car in it. It's going to have an employee, a salesperson object, and then it's going to have a manager object. We would have to decide whether a dealership can hold only one car or more cars. And we would also have to decide whether the car is limited to a specific dealership or could be shared among dealerships. Now, if I correctly recall, where they're taking this is that the car works for only, one dealership, but that you could have a manager who manages multiple dealers. So these would be other classes, right? We have a class car, up here, and we have a class salesperson up here. We have a class manager up here with all the information about each. So if a car is going to, if a dealership is going to hold more than one car, should it just be a single object like that? What would be a better way? How could you hold, and I just about gave it away, multiple cars inside one dealership? We've studied methods of holding multiple objects. If you had multiple numbers, what kind of structure would you put them in? Yeah, you could put them in an array, or you could make them an array list. I might make an array list. Array list of cars, car list, like that. Now something better actually create it. But maybe each dealership only has one manager, so maybe I would not create an array list of managers. Probably want an array list of salespeople. Let's go on with their example. Here's what they show. The dealership, the car to dealership, cars are exclusively owned by the dealership. However, you can have a manager who manages more than one dealership, and you can have salespeople who work at more than one dealership. And then they put these little numbers here, indicating that the star means you could have many, many cars. It's not just a one-to-one relationship. But they're saying that a manager, there's only one manager per dealership. And again, you could have multiple salespeople. Now, if that's the case, I don't really remember why there's a one on the top row, but maybe it'll come back to us. That's a UML version of it. So far, I've only seen UML, which consider the name of the object and the list of the data and the list of the methods, right? Here, we're not so concerned about the data and the methods. We're concerned about the hierarchy of them. It's still UML, but it's a relationship UML. So that's a composite. It's a one-to-one. And this is an aggregate, because you could have a manager owned by more than one dealership. Ooh, did it say down here? So the diamond goes next to the container class. The labels are called multiplicity values. They indicate the number of object instances for each of the two connected classes. Many salespeople, many cars, only one manager. So to implement a program that uses aggregation and composition, you define one class for the whole. And then you go in and you define separate classes for each part. For a class that contains another class, you declare an instance variable. So back over here, we only have one manager. No, that's not right. Yeah. We only have one manager, so it needs to be an instance variable. And the instance variable holds a reference to one or more of the contained class's objects. How could it contain one or more? You'd put them in an array or an array list. So typically, if they have more than one, if they have star multiplicity values, you use an array list. If two classes have an aggregation relationship, then store the contained class object in an instance variable, but also store it in another variable outside the containing class. So the object can be added to another aggregation and have two owners. So you're just going to have another place to hold that particular object, that particular sub. I'm not really as interested in explaining that. If two classes have a composition relationship, then store the contained class's objects in an instance variable in the containing class, and do not store it elsewhere. That way, the object can only have one owner. So, what they're saying here is that since we could have more than one, the salesperson, okay, let's do the manager because we can only have one manager. The salespeople should actually be in an array list, so I'm going to kind of ignore them. But the manager object, somewhere else you're going to have that manager listed. And then when you create your dealership, you'll either, pass in, or you'll have a set manager. Like that. And so you have a setter for the manager. And why do you do that? So even if this object goes away, you still have that manager. It doesn't get cleaned up by the garbage collector just because this got cleaned up. Because we could conceivably create another dealership and set them to the same manager if the same person manages more than one car, more than one dealership. Now the cars are individual to that dealership, so we don't have to store it elsewhere. And that storing it elsewhere doesn't have to just take place like in the main method or whatever. As long as you just have the ability of storing that thing in a place where it's held in more than one object and where it won't get destroyed if that object falls out of scope and the garbage collector eats it. So inheritance, some good stuff. Not that the other wasn't good. We've already been using composition the whole way through. We have not been using aggregation. Our composition has been, strings for people's names and, dog breeds and stuff like that. There are different ways that classes can be related. We've covered aggregation and composition, where one class is the whole and then you have it made of parts. That's called has-a, like is-a and has-a. A dealership has cars. A dealership has a salesperson. A dealership has managers. Don't know why I put the word object there. Whatever. And it's bugging me too much, so I'm going to put an array list of salespeople as well. Right, okay. And then you have is-a. Like you may have a class called dog. And then you have some subclasses, which this textbook calls child classes. And the pit bull is a dog. So is the Chihuahua. So is the Cocker Spaniel. So is the Doberman. Is a dog. Now a dog has teeth, meaning that every pit bull has teeth. A dog has, vaccination date or whatever. Dog has color. So the pit bull has teeth. The pit bull has a color. These are has-a relationships. Is-a is done by inheritance. You create a dog class, and then you inherit its properties into the pit bull, so that the pit bull is everything that the dog class is, and it may be more. Like what if you were doing kind of a hierarchical thing where, you have an animal class, and then you have a fish class underneath it, right, as well as a mammal class underneath it. The animal class is the basic information about every kind of animal. And then the fish class has more specialized information, dedicated only for information about fish. The mammal class has specialized information that's only, pertinent to mammals. So to do this, we would create a class named dog, and it has teeth. I guess we'd make that Boolean as to whether it has teeth or not. And we'd make a string called color. And then we would make another class called pitbull. And this would extend the dog class. So extend is the inherit keyword. C++ uses a different way of doing it. They just put colon rather than the word extends. I think it's actually extends rather than just extend without an S. So this means that the pit bull has everything that a dog does plus more. Now honestly, I can't think of something that a pit bull has that no other dog has. So I'm not coming up with a great example there. But you could have vehicle, right? You have a class vehicle, and a vehicle could have a top speed, right? And then you could make a specific type of vehicle, a class airplane, which extends vehicle. And so airplanes have something that mere vehicles don't. They've got wings. How many wings do they have? Then you could have another class, boat, which also extends the vehicle class. And we're kind of ignoring the fact that you could have flying boats, right? That's a kind of a different kind of relationship. And so what does a boat have that a plane doesn't have? I don't know, a sail or a propeller, you know. So does it have a sail? Like that. So we've created a hierarchy. This is the root class using C++ terminology. And these are these child classes, parent class and child class. Vehicle is the parent to airplane. Vehicle is also the parent to boat. Now in this book, in this language, they like to call them superclasses and subclasses, I believe. I better flip past it, a few slides and make sure. This is the superclass. Now superclass makes it sound like it's the best class ever. Dun, da, da. But it's actually the subclasses that have more abilities because they have more traits added to them. So don't be fooled by the term super. It just means, the topmost in the hierarchy. And then the subclasses, each subclass adds some kind of functionality to it. And if you wanted to, you could make a different kind of boat. You might make a submarine, which extends the boat class, right? And whatever a submarine has that a boat doesn't have, maximum depth. So a submarine could indicate whether it has a sail or propellers, I should not be capitalizing all that stuff. So you would say that a submarine, you could specify whether that submarine has a sail or propeller, probably not sails, and it picks up that information because it is a boat, it's an is-a relationship, and it also picks up some additional information, which is that a vehicle has a top speed. So if you wanted to, you could create a submarine. Equals new submarine. And you could set all of those values. S1 dot maximum depth, is equal to 200 meters. S1 dot propellers is equal to true. S1 dot top speed is equal to 30 kilometers per hour, or however fast. But a plane cannot set those things. Or a boat cannot set all those things. Let's do the plane now. All the plane does is have wings. So plane P1 is equal to new plane. Well, we could set its top speed, P1 dot top speed. The plane goes super fast. And then he doesn't have propellers and he doesn't have a maximum depth, but he does have wings. So we could list how many wings he's got. Hope that makes sense, kinda. Hope we're seeing that the superclass, the topmost class, is the one that the others are inherited from. And ultimately, everything extends the object class, which Java gives us. And the object class has dot equals and toString and stuff. But you don't put that word there. It's kind of like the default constructor. It gets provided for us. So in this case, we have boat, which is a subclass of vehicle, and it's a superclass for submarine, right? Because it's above submarine. Submarine is a subclass of vehicle, which is a subclass of vehicle. Excuse me. Submarine is a subclass of boat, which is a subclass of vehicle. So here's their UML example. You have a person. He's got some information. He's got a name. And then a customer is a person. So when we define the customer class, we would say customer extends person. And a customer has a different piece of data that we care about, the address. So every customer has both a name and an address. Also, we have employees, and for some reason we've decided we don't care about the address of an employee. So the employee class is not extending the customer class, it's extending the person class, but every employee has an ID. Every employee also has to have a name. Then we have two different kinds of employees. We have a full-time employee and we have a part-time employee. And they each have little bits different information. A full-time employee has a salary, a fixed salary. A part-time employee has an hourly wage. So every full-time employee has a salary and an ID and a name, whereas every part-time employee has an hourly wage and an ID and a name. So as you go down the hierarchy, the classes get more specific. The customer and employee classes describe different types of people, persons. So inheritance terminology. Pairs of classes are linked together. This is linked to that one. This is linked to that one. This is linked to that one. The more generic class, the one up, is called the superclass. The more specific one is the subclass. And the way we call that is we say that subclasses are derived from the superclasses. Unfortunately, the term subclass and superclass can be confusing. Super does not imply that it has more ability. It actually is the other way around. Subclasses have more capability. They can do everything the superclass can and more. We'll stick with the term superclass and subclass, since those are formal terms used by Oracle, but know that people often call them base class and parent class. And then you have child class or derived class down at the bottom. So the base class is the one up at the top, also known as the parent class, and then you have the child classes underneath. And I kind of like that terminology more than super and sub, but that's probably because that's how I was taught. Alrighty then. I want to stop talking about this chapter because I want to go to our next assignment. If we look, we have a new, oh, by the way, we have a Dropbox K so that you can submit your .java file. But here's our assignment. Piggy Bank 1. Don't just steal their bank class. I'll be able to tell if you did that. I'm going to throw a fit if the attached document is not in it. All right. What the Piggy Bank class is going to do is the program is going to ask what kind of coin to add. And you can type in, I want a dime. Or maybe you present a menu. 1 for dimes, or 1 for pennies, 2 for dimes, 3 for quarters, whatever. 0 to quit. They choose penny, and so adding penny to bank. Bank has 1 coin worth that. And then it asks again. So that's assuming that they entered a 1, right? And so then again we ask what kind of coin to add. This time I'm going to add a dime. And so adding dime to bank. Or we could make it more generic, adding coin to bank. Maybe we don't want to say that type every single time. If we're going to simplify it, you can make this as cool as you want. And so now that we've added that coin to the bank, coin has 2 coins. I don't care if you figure out how to do the S or not. And how much is that worth? Okay, that's worth 11 cents because we've added both a penny. If you keep adding coins, you're going to hit at some point where bank has 50 coins worth, whatever our amount is. $7.41 or whatever, right? Then you try to add another one. They try to add a dime to it, but instead of saying adding coin to the bank, it says bank is full. And since the bank is full, the next time we come along, we're going to quit. Okay, goodbye. That's how it's going to work. That's the user interface. It doesn't have to be exactly that, but that's the idea. If you want to make them type in .01 for a penny and .10 for a dime, that's fine. If you want to present a menu like that, that's fine. If you want to let them type in the whole word, that's fine. You have choices. The functionality that I care about the most is the ability to keep track of how many coins, keep track of the total value, make sure they cannot add more than 50. And I want this to be separated into two things. A piggy bank class that manages how many coins you've added to it. So the piggy bank class is going to have some kind of structure for holding numbers. I suggest an array list. Yeah, you could just make an array that has room for 50, right? But make it an array list. We've kind of already seen that array lists are that way you could count how many coins are in the array list by just doing array.length or list.length and get its dot size and then return that. And then to add up the total value of the array list, you use a for loop or for each loop, and you get all the values of the coins out of it. So I would have an array list in it, and I would have a .add or @coin method in it, and I would have a get value and a get number of coins method. That's kind of the minimum. And my instructions go into more detail. It provides a UML, listing of stuff like that, but have a client class with a main that does all that looping, does the I/O, and uses the piggy bank class. And then you're going to have a piggy bank class with an array list of, I would make it doubles, right? So that you could hold .10 or 0.25 or whatever. And then it's going to need an add coin method where you pass in the value of the coin. Or if you want to cook up something else where you pass in a 1 and a 1 means penny and a 2 means dime or something like that, you could do that. It's going to have a get number of coins. That may not be the exact method name that I came up with that returns the number of coins, and get value of coins in the bank. That's kind of the minimum, right? Add coin could return true or false. False if it couldn't add it because it was full. Or your program could just check the count before it calls it. Or you can add a is full method. You have freedom on how to do all that kind of stuff. This should be an int, and the value of the coin should be a double. So that's the kind of UML. Does that make sense? We're going to come up with a more complex version of this next, so I call this the apprentice version. The next version is going to use inheritance, and so I'm going to call that the Jedi Master version. But get this one done, and this is something that we can do absolutely without inheritance, but it's going to exercise your brain a little bit. And we're going to be using a composition relationship. The bank has coins, but the coins are not shared between two banks, right? Because those coins belong to that specific bank. I couldn't come up with a good example to throw in aggregation into this. Aggregation is aggravation. All righty. That enough? Are we happy? Do we have any questions over what we've talked about? You usually have questions. I'm going to come over here and look at you. No, I'm kidding. Kidding.
I do have a question. It's not Java related.
Okay, all right. Then I'm going to end the recording. When I get downstairs, I will upload these instructions to it. I'm so ashamed that they're not there. Well, let me show you what they look like, because I did the Jedi version, and they look real pretty. La-di-da. Like this. Ooh, pretty. Piggy bank assignment. And then it shows the, data for it and some UML and stuff, and then it shows, a sample run and stuff like that. So that's what you're going to see when you pop it up, but this is for the more advanced version. Alrighty. See you all next week. Stop the recording and we can chat.